Hello everyone, welcome back to JEE. Today I am back with another video where we'll be discussing the maths question from Alan Pre-Score paper of 12 October 2025. This paper had good questions from coordinate geometry and conics. So let us begin. So the first question is saying that let tangents PA and PB be drawn to the parabola y minus 2 whole square is equal to 8 multiplied by x minus 3 from a variable point P whose coordinates are h comma 2 minus 2h, where h is a real number. So if chord AB passes through a fixed point 5 comma 2, then we have to find the area of the triangle found by points P, A and B. Okay, so this is a very nice question. So let us see. So first of all, we need to analyze the equation of the parabola that has been given. So this is the equation and we have to compare it with the general form. So this is the general form y minus k whole square is equal to 4a times x minus h, where the vertex is h comma k. So generally the formula is 4 y square is equal to 4ax when the when the vertex is at the origin, but here the origin has been shifted to some other point. So we need to use the transformation formula. So we get this standard formula, and the vertex, we can find out that the vertex will be at 3 comma 2. So vertex is at 3 comma 2. Now value of a we can find out as 2 because 8 is equal to 4a, so a would be equal to 2. And focus of this type of parabola is given as h plus a comma k. So in general parabola, for this kind of parabola where the vertex is at origin, the focus is at h comma 0. But here, since the vertex has been shifted to h comma k, so we need to use the transformation formula, and we will find out that the focus is at h plus a comma k, which comes out as 5 comma 2. So notice that this focus is the same point through which the chord AB was passing. So the chord AB is passing through the focus, right? This is the first thing that we got. So this fixed point is the focus. And directrix will be at h minus a. So x is equal to 1. Okay, so now we found out that the chord which is connecting the point of intersection of the tangents of the parabola with the parabola. So these are the tangents, right? PA and PB are the tangents and this is the chord. And we know that if the chord of the tangent is passing through the focus, which it is passing, it was given in the question. So if the chord is passing through the focus, so the tangents at the end of the chord must meet at the directrix. So the tangents are meeting at variable point P, and this variable point P must be on the directrix. Okay, so and we are also given that the coordinates of P are h comma 2 minus 2h. So this is the parametric form and we will convert it into x and y. So for converting it, we can take x is equal to h and y is equal to 2 minus 2h. From here, we can replace h as x. So we will get y is equal to 2 minus 2x, which will give us this equation. So the point P is lying on this line. And we also know that point P is also lying on the directrix. So where the line 2x plus y minus 2 is equal to 0 and x is equal to 1, this is the directrix. So where these two lines will meet will be the point where P is located. Because P is lying on this line also and P is lying on this line also. And this is possible only when it is lying on both the lines, and to lie on both the lines, it must be at their intersection. So if we find out the point of intersection by putting x is equal to 1 here, we will get 1 comma 0 because y will come out as 0. So P point we have got, which is equal to 1 comma 0. Now we have to find the area of this triangle. This is the chord AB, which was passing through the focus of this parabola. So this was the focus. So one thing we know that we have a general formula for finding the area of a triangle. So for a parabola whose equation is s is equal to 0, we will see what this means if you don't already know this. So for a parabola s is equal to 0 and an external point P, the area of triangle found by P and the chord of contact is given by this. So this is the formula which we will be using, and I will prove this also. So I will be proving this formula for a general parabola y square is equal to 4ax, and this will be valid for all parabolas if you shift the coordinate to the vertex. So this is the parabola. So this will be the parabola. This will be at the origin only. So assume that P is any general point x1 comma y1. So tangents, if tangents are drawn to this parabola, then the chord of contact will be this line, which is connecting the contact points of the parabola and the tangents. So this area of this triangle will be given by s1 raised to power 3 by 2 by 2a. So what will be the formula for the area of the triangle? So area of the triangle will be half into base into height. So base is this and the height is this. So let me define some general notation. So S, which is the equation of the parabola. So S is the equation of the parabola, which is y square minus 4ax is equal to 0. So this is what we meant when we wrote S is equal to 0. This was the formula of the parabola. Now S1 is defined as value of the parabola, which is value of S at x1 comma y1. So this will be y1 square minus 4ax1 is equal to 0. So we have just put y1 comma x1 comma y1 in this equation. So that is s1. Now we know that equation of chord of contact. So the equation of this line is given as t is equal to 0, where t is y into y1 minus 2a x plus x1. So how we transform this to this is that wherever we have a variable which has square, we write it as y and y1. And wherever we have power of 1, we write it as x plus x1 by 2. So that 2 got cancelled with the 4, so this became 2. So this is very general formula. You must have read it when you were doing the theory for parabola. So this is equal to 0. So this gives us the equation of this line. And this can be written as 2ax minus y1y plus 2ax1 is equal to 0. So this line is given as 2ax minus y1y plus 2ax1 is equal to 0. Okay, so now we got the equation of this chord of contact. Now I will name this point as A and this point as B. So first I will find out the height. So let me name this as C, and this is perpendicular because the height is perpendicular to the base. So height is equal to length of PC, and we know that to find the distance of a point from a line, we have the formula that if the equation of this line is ax plus by plus c, then we will put x1 y1 in that equation, and we will divide it by a square plus b square square root. So I will be using that formula. So length will come out as, so 2a, and I am putting x1 minus y1 multiplied by y1 plus 2a x1 divided by a square, which is 2a here. So 2a square plus minus y1 square. So this will come out as modulus of 4a x1 minus y1 square divided by root of 4a square plus y1 square. And notice that this is s1 only. So I will write this as modulus of s1 divided by y1 square plus 4a square. Now I have found out the height and I need to find out the base. So base is given as length of AB, and if A point is x2 comma y2 and B point is x3 comma y3, then the length will be given by the distance formula, which is x2 minus x3 whole square plus y2 minus y3 whole square. So I basically need to find x2 minus x3 and y2 minus y3. So I will be using a better form of calculation here. So instead of finding out x2 comma y2 and x3 comma y3 separately, I will be directly finding out the difference of the x's and the y's. So chord of contact we know was given as y1 is equal to 2a x plus x1. So to find out x2 comma y2 and x3 comma y3, I can find out the intersection of this chord of contact with the parabola. So the equation of parabola was y square is equal to 4ax. Now I need to find out the intersection between these two equations. So I will be putting the value of x from this equation to this equation, which will give me y1 is equal to 2a. So x will be y square by 4a. So y square by 4a plus x1. Now expanding this, I will get y1 is equal to 2a y square by 4a plus 2a x1. y1 is equal to y square by 2 plus 2a x1. So I am taking the LCM now. So I will get 2 in the denominator and I will take this 2 here, cross multiplying it. So I will get 2y1 y is equal to y square plus 4a x1. Now I have gotten a quadratic, right? The intersection must be at 2 points. So that is consistent with our results that we have a quadratic, and this will have 2 roots, which will give us y2 and y3. So from here, this can be written as y square minus 2y y1 plus 4a x1. So from quadratic formula, we know that y3 plus y2 will be given as minus of minus 2y1, which is 2y1, and y3 multiplied by y2 will be given as 4ax1. This is minus b by a, and since a is 1, so there is nothing in the denominator. This is c by a. So y3 minus y2 whole square can be given as y3 plus y2 whole square minus 4 y3 y2, which will give us 2y1 square minus 16ax1. So this will be 4 times y1 square minus 4ax1, which is basically 4s1. So this part we have gotten, and we need to find x2 minus x3 whole square now. So now I will be finding out x2 minus x3 whole square. For this, I will be using the equation of the parabola. Since I know that y1 and y2 and y3 are the corresponding y's of these x's, so I can write x in terms of y. So y2 square by 4a minus y3 square by 4a whole square is this quantity. So y2 square minus y3 square I have to find out. I know y1, y2 minus y3 and y2 plus y3, so I will be using that fact. So this will transform into y2 minus y3 multiplied by y2 plus y3 divided by 4a whole square, which will give us, so y2 minus y3 would be square root of this thing. So y2 minus y3 whole square we know is 4s1. So y2 minus y3 will be root of this, which is 2 root s1, and y2 plus y3 is equal to 2y1 divided by 4a whole square. This will be equal to y1 square multiplied by s1 divided by a square. So we have all the components of the length formula. Now I will be finding out the length. So length of AB will become root of this x2 minus x3 whole square, which was y1 square s1 by a square, plus of this 4s1. So simplifying this by taking the LCM, I will get y1 square s1 plus 4s1a square divided by a square, which is equal to root of s1 multiplied by y1 square plus 4a square divided by a. I have taken this a square out of the root. Now I have the height, I have the base, and I need to multiply them with half. So area of the triangle will be half multiplied by the height, half multiplied by the base. So base is length of AB, which was this, multiplied by the height, which we found out as mod S1 divided by root of y1 square plus 4a square. So this and this will get cancelled, which will give us S1 times S1 raised to the power 3 by 2 divided by 2a. So this is what we had to prove, and we have proven this. So I will be using this formula to find out the area of the triangle PAB. And remember what was S1? S1 is the equation which we obtain on putting the coordinates of P inside the equation of the parabola. So equation of the parabola was this, and if I put P inside this, I will get S1 as 20, and A we already found out was 2. So I will finally get the answer as 10 root 5 square units. So this was a very nice question. Hope you all understood the derivation and the method I've used to solve this question. Let me know if you have any doubts or any other method of solving this. Now moving on to question number 2. This is a bit easier as compared to question 1 and a bit shorter also if you have solved these kinds of problem before. And if you have not solved these kinds of problem before, then it will be very difficult. So the question says that if f of x comma y is given as root of x plus 9 whole square plus this whole squared plus this similar to this first term and this third term. So we have to find the minimum value of x comma y. So this can probably be solved by taking the differentiation of this and setting it to 0 and then putting the value of x and y. But we have a easier method to solve this. So if you look at the first term, you will notice that this 9 and this minus 9 and 8 are a fixed point. So we can denote this minus 9 comma 8 by a fixed point, and this is the distance formula of distance between A and point B, whose equation is given as x comma root 16 minus x square by 2. Similarly, the second term is the distance between y comma 2 root y and x comma root 16 minus x square by 2. And third term is also the distance formula between C point and D point, which is 3 comma 0, because this is 3 and we can write this as y minus 0. So this function is basically this, that if you have a point A minus 9 comma 8 and if you have a point B which has a parametric equation this, and has the parametric equation y comma 2 root y, then this will be a parabola, and D is a point 3 comma 0. So let us see in detail. So point B will be an equation of ellipse, because we have the parametric equation x comma root 16 minus x square by 2. So this denotes the general formula for any point on the ellipse. Why? Because if we take this as y, so y will be equal to root 16 minus x square by 2, which will give us 2y is equal to 16 minus x square. And if you square this, you will get 4y square is equal to 16 minus x square, which finally gives us x square by 16 plus y square by 4 is equal to 1, which is the formula for an ellipse. So this will be the parametric form of an ellipse, parametric form of any point on an ellipse. So this B point can be any point on this ellipse. It can be here also, it can be here also, it can be here also. So if B point would have been here, then AB would have been this distance. And then BC would have been this, and CD would have been this. Only A and D are fixed. B and C are variable points, which can take any value on the shape that they are lying. And y comma, similarly, y comma 2 root y will be the equation of a parabola. I have given the derivation here. So we need to find out when this distance will be minimum, because C can be here also, C can be here also, right? C can be here also. But we know that the distance between any 2 points is minimum when they are distance between any 4 points passing through them will be minimum when they are lying on a single line. Because if they are not lying on a single line, then the distance will increase. So these 4 points must be on the straight line, which gives us that we can simply find out the distance between minus 9 comma 8 and 3 comma 0. So if you apply the distance formula, you will get the answer as root 208. So this was the answer. So the question 3 says that if length of the tangent drawn from the focus of the hyperbola x minus 2y plus 3 whole square minus of 8x plus 4y plus 4 whole square is equal to 20, to its director circle is p by root q, where p and q are co-prime, then p plus q is, so we have to find the value of p plus q. Okay, so first we need to focus on the equation of the hyperbola that has been given. So this is not the general equation of the hyperbola that we are familiar with. This is because it is a different special kind of equation of variation of the formula of a general hyperbola. So the general formula of the hyperbola that we are familiar with is when the transverse and the conjugate axis of the hyperbola are parallel to the y and x axis. So something like this. So this is the vertex of the hyperbola, and something like this would be happening. This is when the general formula of hyperbola works. but it is possible that the conjugate and transverse axis are not parallel to the x and y coordinate axis, right? It can be like this also. So in this case, the general formula of hyperbola won't work. So what happens in this case is that, so let us see, when the hyperbola's axes are not parallel to the standard x and y axis, its equation can be represented with respect to the two perpendicular lines. So first point is that coordinate transformation has to be done. So imagine we have any point P, x comma y. So in the normal coordinate system, this has coordinates x comma y. But in the new coordinate system, which has the origin at the intersection of the transverse and the conjugate axis, this can be taken as, the y coordinate can be taken as the distance from this axis, right? So the distance from this axis is the y coordinate and the distance from this axis is the x coordinate, right? So we will be applying the distance formula for a point from a line. So we know that if this line is given as ax plus by plus c, so this has a slope of, so if I convert it into y is equal to mx plus c, I will get y is equal to minus a by b x minus c by a, sorry, minus c by b. So the slope is minus a by b. So the slope of this line must be b by a, because we know that perpendicular lines have a slope product of -1. So the product is now -1 of their slopes. So the equation of this line would be y is equal to b by ax. So the equation of this line can be finally given as a times y minus bx minus some other constant c dash is equal to 0. So this line has the equation this. So now we can find out the distance from these two lines. So the distance from this line would be given by, if we put x naught and y naught in this. So if we take p as x naught and y naught, then the distance of p from this axis would be ax naught plus by naught plus c divided by a square plus b square. And the distance from this axis would be this b1x minus a1y plus c2 divided by a square plus b square. So we have applied the distance formula for both the lines. So for hyperbola, the general equation is x square by a square minus y square by b square is equal to 1. And this is with respect to the standard coordinate axis. So standard coordinate axis is not this axis. It is the axis which is containing the vertex. So this is the standard coordinate axis, and with respect to this coordinate system, the equation of hyperbola is capital X square by a square plus y square by b square is equal to 1. So if we want to convert it with respect to this original axis, we have to use this formula, right, which we obtained. So this is the equation that we will be using to solve the question, because we can see that this is of the same form. So if we write it in this form, x square, this thing is the same, and if we take out 4 common, we will get 16 out of the square. So this is the equation that we are working with, and if we divide it by 20, we will get this. Now we need to write this in this form, because you can see that if this was a was 1 here and b was -2, then a became 2 here and b became 1. So this is like perpendicular lines. This line is perpendicular to this line because the slopes have a product of -1. The slope here would be, half, and the slope here would be -2. So the product is -1 of the slope. So these lines are perpendicular. So this must be of this form, where two perpendicular lines are forming the standard coordinate system for the hyperbola. So we can convert it into this form by some manipulation. So you can see that root of 1 square plus -2 square is equal to root 5, and we have to take square of that, so it is 5. So 5 multiplied by 4 is 20, and here there is 16 above and 20 below. So we can see that if we divide this by 1 by 4, then we will get this term. So from here, if we write this as x and this as y, so we will get x square by 4 minus y square by 1 by 4 is equal to half. So this means that with respect to this coordinate system, so if this is the origin, then the equation of the hyperbola can be given by this formula. X and y, capital X and y are with respect to this origin. So this is what the actual hyperbola will look like. I've plotted it as a graph. So if we take this as origin, then the equation of this hyperbola is x square by 4 plus y square by 1 by 4 is equal to 1. Sorry, there was a minus here. So now we need to find out the director circle. So director circle is the set of all points from which two perpendicular tangents can be drawn to a conic. So from this point, if I draw two tangents, so this will be perpendicular here. So the equation, we know that equation of directrix circle. So equation of the director circle with respect to the standard coordinate system, which is this tilted coordinate system. So this is given as capital X square plus y square is equal to a square minus b square. So the equation of the director circle can be given as x square plus y square. Sorry, this square won't be here because a was 2 and the square will be 4, and this squares won't be here. So this is the final equation of the director circle, and this is the equation of a circle. So this will be r square. So the radius of this circle is root 15 by 4. So what was the question asking? The question is asking us to find the length of tangent drawn from focus to its director circle. Okay. So if this is the focus here and this is the focus here, so we need to draw tangent from this focus to the director circle, and we need to find the length of this segment, right? Length of the tangent. So we don't need to find out the point of intersection, right? Because we know the radius, and if we find out this distance, then we can directly write the length of this using Pythagoras. Let us find out what will be the what will the coordinate of the focus in the new standard coordinate system. So with respect to this origin, what is the coordinate of the focus? So we know that E is given by 1 plus b square by a square, and b was 1 by 2. So we will get 1 by 4 here, and a was 2. So we will get 4 here, which will give us E as root 17 by 4. And so we know that the distance of focus from the center is given as AE, and A here is 2, so it will be 2 root 17 by 4, which is root 17 by 2. So this distance is root 17 by 4. Now we need this radius. We already know that this is equal to root 15 by 4. So we can find out this distance using the Pythagoras theorem. So length of tangent will be equal to this distance squared minus this distance. Sorry, this was square. So the length of tangent squared is equal to 1 by 2. So the final answer would be root 1 by 2. So this question became easy because we have used the transformed coordinate axis by taking this as the x-axis and this as the y-axis and taking this as the origin. If you try to solve it with this original coordinate system, then it will be a bit difficult. Also, you need to understand that the general formula is with respect to the standard coordinate axis, right? This is not with respect to the original x and y that we know. This is not with respect to this y and this x. The standard formula is with this respect to this. So here this will be capital X and not small x, and this will be capital Y, not small y. So you have to use this transformation formula. So hope you liked my video, and I will be bringing the next question solution in the next part of this video. Don't forget to like and subscribe and give me feedback on my comment section or on my Telegram. So bye everyone.